The lesson outcome for this video is I can factor quadratics, and this will involve both factoring out a GCF and factoring a quadratic when a equals 1, as we have been practicing. So really what this is going to do, it's going to connect our GCF work with our current quadratic factoring work. So here are the steps we're going to follow. Number 1, we're going to find the GCF. Typically there will be 3 terms. Step 2, we're going to factor out that GCF, as we practiced in the previous unit. And step 3, we're going to factor the remaining trinomial or quadratic expression. All right, so let's try this example right here. Okay, 3x squared plus 6x minus 24. Be sure to write that in your notes. And what we're going to do for step 1 is we're going to ask ourselves, is there a numerical or variable GCF? And at this point, we don't need to worry about if these are the factors are positive or negative. So I'm going to show this work the same way right here as we did in a previous unit. So what are the factors of the first term, and then the second term, and then the third term? That's what we're going to do so we can find our GCF. So 3x squared. Well, we know the factors of 3 are 1 and 3, and x squared means we have x times x. Our factors of 6. Well, we have 1 times 6 and 2 times 3. We also have an x. 24 has a lot of factors. 1 times 24. It's divisible by 2, 2 times 12. It's also divisible by 3, 3 times 8. And then 4 times 6. We look for a greatest common factor that is numerical first, so the number GCF. We have a 3, hopefully you noticed, in every one of these 3 terms, so we can put our 3 right here. Then we look to see if every single term has an x, or a variable. And in this case, there are 2 x's in the first term, there's 1 x in the second term, but there are no x's in the third term. So we will not put an x in our GCF. So that means after this, what we're going to do is we are going to factor out that GCF. Whoops, apologize for that. We are going to factor out the GCF we found in step 1. So we're going to put that GCF right here, just like, again, in the previous unit. And we're going to say what is left in the parentheses. Notice that my 3 terms, I still have 3 terms, and one of them, between the first 2, there's a plus, and between the second and third, there's a minus, so I have those in there. So, if I factor a 3 out of the first term, 3x squared, I will be left with x squared. I could put a 1 in front, because 3 times 1 gives us that 3 right there, but I don't have to write the 1. Then the second term, 6x, if I factor 3 out of 6, it's 3 times 2. That will give me that 6, so 2. And then the x that is in that term will remain. And then lastly, I have the 24, and the negatives already accounted for. That 24, if I factor out a 3, it's 3 times what value gives me 24, and that is 8. Okay, so now our third step is to factor the quadratic expression that remains in the parentheses. Remember to leave the GCF out in front, so we're just going to recopy that right here, and we are just going to focus in on this right here. Well, as you know, in class we've been writing our C term in this rectangle off to the right, and then we list all the factors of negative 8. Well, 1 times 8 is 8, but we need one of them to be negative, and 2 times 4 is 8. And we need one of them to be negative. And then we add, so negative 1 plus 8 is 7, and negative 2 plus 4 is 2. We need this 2 right here because it matches our B term, so we know our factors are negative 2 and 4. So we can now put x minus 2 and x plus 4 in our parentheses, and we have done what is called factor completely. We factored out the GCF, and then we factored the trinomial. If I were to FOIL these 2 binomials, and I would get this, and then distribute the 3 back into this trinomial, I would arrive at my original expression. Okay, and I'm just going to do one more step with you, or one more example here with you, and then we will practice more in class. Our first step, remember, was to, or is to, find the GCF between our three terms. Some of you are going to get really good at just noticing what the GCF is between the three terms without writing all the factors and circling the common ones. If you are at that point right now and you can factor out, going right into step 2, if you can factor out the GCF and write it here and then tell me what's left in the parentheses, that is fine and you can go that route. If you need to write out the factors and circle them, that's fine as well, and that's what I'll do in the video, but if you don't need this, you won't have to do this on every question. So our first term is 5x squared, and we will list our factors of 5, which are 1 and 5, and then we have x times x. Our second term is, again, we don't have to worry about the negative, 35x. 35 is 1 times 35, and then 5 times 7. And we have an x, sorry. Our third term is 60, and 60 has more factors. I'm going to kind of run out of space here, but 1 times 60, 2 times 30, we have 3 times 20. I'll just kind of keep writing them. 3 times 20. It is also divisible by 4, 4 times 15. It's also divisible by 5, and that's 5 times 12. And 6 times 10. Sorry about that, that's kind of messy, but there's a lot of factors of 60, and that's them right there. So 1, 2, 3, 4, 5, 6 are all factors, and then 10, 12, 15, 20, 30, and 60. All right, you might have wanted to write those all in one long line like we typically do, or as factor pairs. Now, if you look, you'll notice that our common factor is, greatest common factor I should say, is 5. A hint is to always look at the smallest number, which is not always the first number. It could be the second number or even the third number. But look at the smallest number and look at the factors of that, and it might help you find the greatest common factor quicker. So if you looked at 5, 35, and 60 and said, oh, all of them are divisible by 5, then you might have really quickly felt like you could write a 5 right here as your greatest common factor. Notice our last term does not have any variables in it, so we cannot factor out a variable. So what we do now is we have our minus right here and our plus right here, just like in our original expression. The only time that'll be different is if we factor out a negative, and then that would change our signs. So keep that in mind if we have to factor out a negative, and we will see that in class. So if I have 5x squared and I factor out a 5, I factor that out, I'm left with 1x squared, or just x squared. And then if I have this negative 35x, I have minus 35x, 35. I divide out a 5, or factor out a 5. I'm left with 7 and the x. And then lastly, I have 60, and I'm factoring out a 5. So we divide 60 by 5, and we get 12. Now, we factored out the GCF. And in our third step, we're going to leave that GCF right here. But for right now, what we have to do, and then we'll have 2 sets of parentheses with our final answer. And we're going to take that C term, again, 12, in this case it's positive, and write that over here. 1 times 12 is 12, and 2 times 6 is 12, and 3 times 4 is 12. We add, and we get 13, and we get 8, and we get 7. Okay, so again, as we've been practicing, we see that this is the number we need right here, 7, but we notice that it's negative 7 that we need. In order to get a negative 7, when we already have a 7 right here, we need to change both of these signs for the 3 and the 4 to negative, which will give us a negative 7 here. Again, that keeps us with a positive 12. When we multiply negative times a negative, we'll still get positive 12, and when we add them, we get negative 7. So we have our factors of negative 3 and negative 4. So x minus 3 and x minus 4.